Hello friends and welcome. So what you're looking at here is my development H-frame, and there's an amp inside it, which is the topic of this video. And I'm going to discuss three things. So one is the sound quality of this amp, and it has some very particular qualities that are outstanding and the best that I've ever built, those qualities. Secondly, I'm going to talk you about through the nuts and bolts of this amp, which means I will detail its very really rare topology that it's using, and you know the stages, the tubes that it uses, and then also about the power supply. In between, I'll also sprinkle some of the core principles of this amp that went into it, and then at the end I will also talk a little bit about, because this is a forced balance differential amp, I will talk about a bit how it compares to single-ended and my feeling around it and how it's going to develop further. So this amp has been in development for over a month now, and it will get some more refinements. So I'll talk about that at the end as well. So, but let's get into some of the sound qualities first, and then so that will sort of give you an idea whether this should be of interest to you or not, because it has a couple of really outstanding qualities. First of all, which is PRET, so pace, rhythm and timing. It is the best amp I produced giving PRET. It is very good. I can see the effect on other people as well. That sort of invites dancing. It's just very engaging rhythmically. There's just absolutely, the timing is just finessed. Secondly, even more remarkable amongst the amps that are built, I call it lifelike presence that it has, but it constitutes about a couple of factors that are all quite remarkable, but they come all together, I feel. So that is, the lifelike presence comes with, it's very fast, it is highly dynamic, and it is highly resolving. So and I mean that with the ability to produce small details while bigger details are coming on. And it does all of this regardless of a bass line, regardless of complexity of the music. And it does this almost regardless of volume. So it means if it's quiet, if it has a strong bass line, it has complexity, it is classical music or it's a simple music, there's a coherency and a naturalness about this lifelike presence and dynamism that doesn't fade or doesn't change with volume. And so what you get as a result is some effortlessness and naturalness about this sum. It just feels unencumbered because it just keeps doing the same thing, and it feels that its sweet spot maybe is very wide, and that's maybe linked to one of the core principles that went into this design, which is that the tubes are only used even at full, as a sort of semi-full volume, at full, you know, my normal listening. Because it probably has at least 4 times more power than what is needed. It just has this effortlessness about it, because it just has loads of headroom. Like it's just not sweating anything. So those are two. Oh, and then there's a third remarkable thing, more for me, but I was just surprised about how well defined the bass has become with this amp. And so I'm using exactly the same speaker setup, which is almost aperiodic, or you know, it has a very heavily stuffed port, so it's, for all intents and purposes, nearing on a sealed cabinet. But the bass line is just very pronounced, but it's very, I can now really hear what the bass is doing. It's not a single note bass, it's a multi-tone bass with character. And that's being brought out by the amp. So that's really those standout qualities. As far as the sound qualities, let's get into the nuts and bolts of this amp. So it is a two-stage amp. It has a shunt volume control, that's where it goes in, and then we got a driver tube. Now the driver tube is a 8532W, sorry. And that's the militarized version of the 6J5, and that tube was made famous by the Darling amp. Now it's used here again, and it's chosen particularly also to produce a very nice harmonic spectrum of the whole amp. And the reason, of course, is because the output stage is a differential stage, and that will have a natural tendency to cancel second harmonics. And I've used output tubes, the 4P1L, which is a directly heated pentode and has extremely low levels of third harmonic distortion. And with this tube producing a bit of second harmonic distortion, you get this overall... Come on, kitty cats. You get this overall very... Absolutely, this amp doesn't, and the topology is more a cause of that as well. It absolutely doesn't sound like a push-pull amp, and the harmonic spectrum, so the overall feel and warmth of the amp is quite neutral, but it's not clinical at all, as you would hear from push-pull, typically from push-pull amps. So, how is the coupling done? So we've got this driver tube. And that actually goes into a Lundell interstage transformer, which has three functions. A, it loads this tube. B, it steps down this tube. So it steps down 4.5 to 2, plus 2. And then it's used as a phase splitter. So it splits the phase, and then we've got two pairs of tubes. So one does the positive phase, the other one does the negative phase, the opposite phase. And then we've got that tube, which I'll talk about in a very short while. So this step down does a couple of things. It loads the tube really high. It makes it largely insensitive to any grid impedance variation of the directly heated tube. And the other thing is it gives a very low output impedance, so it drives these tubes properly, and it definitely sounds like it. Since I've put the current reasonably high, so I think at the moment it's about 32 milliamps for each tube, which this tube really needs. So it's at the top end of its specification. So it's 7.5 watts dissipation, and it's really sitting there, and it's really needed with this tube to actually have it sound not give that hollow mid-range that it's sort of known for. So that effect is completely minimized in this amp. So as I said, this tube actually provides a majority of the bias, and the reason this is the EZ81 rectifier, so it's a full wave rectifier, and it has two half wave rectifiers inside it. So one half wave is used for this pair and one half wave is used for that pair, and that causes these tubes to be balanced in pairs. So they are allowed basically to balance out as a pair rather than having to have an exact matched quad. So it's I find it's fairly insensitive to what it does. You just need to balance out the current, sort of as in a matrix almost. You balance the totals out, and then it works well. So this provides the bias, and it does another thing. And it uses an extra resistor. So this is a common cathode resistor at the bottom of this, and that in total does a couple of things. So this tube, being a diode, doesn't allow any AC path to travel over it, because it only allows current in one direction. Now that is a way of forcing these tubes, the AC return loop. With push-pull amps, typically the AC return loop runs via the capacitor in your power supply. Now with this in place, there is no AC loop that runs through the common cathode. So its AC return loop runs through the two tubes in series through the output transformer, and the same for here. Just a little bit about this connection here. The 4P1L, the top three elements, so the screen, the suppressor and the plate, have been fused together with some small resistors. And there's a small resistor as well between each pair, the top of each pair, into the output transformer. So that allows this individual balancing thing to happen. And I feel that these tubes therefore are not fighting each other or are taking away dynamics, which can happen when you have multiple tubes in an output amplifier. So then there's only one component left as far as the active amplification stage part of the amplifier, and that is the output transformer. Now the output transformer is again a Lundahl, and it's an amorphous core push-pull output transformer. It's actually a headphone output transformer because that's what I wanted, because I wanted very low winding ratio and very minimal influence of the output transformer, and experiment with that, and it's paying off. So I think one of the reasons of its fastness and transparency is this output transformer. And I must say, of all the amorphous core that I tried out so far, the Lundahl is by far the one that has the least amorphous core like input. And this is a new transformer, it hasn't been burned in. Like with those Chinese cores, it took a year for them to actually start playing reasonably, and I could still hear the amorphous core more than I hear it in this amp. So well done Lundahl on their amorphous core. They aren't cheap, but I would say in this capacity for a differential amplifier, it is really, I'm very impressed with the quality, the sound. This is the first time that I don't feel that I hear the output transformer. And not only that, I can sort of attest to it, because one of the experiments that I did with this amp is how normally the B plus feeds the output transformer, and then you got the tubes. Well, I started experimenting with putting a choke in between. So I ran 3 experimental setups. So normally fed from the capacitor, so then it's actually really the DC link capacitor that feeds the output stages. Then I put a iron core with 60 Henrys and 170 ohm DCR, and then I put an amorphous core with 7 Henry and 22 ohms, so very low DCR choke. And with each I could hear the material, so I got the plasticky sound of the DC link capacitor, and then I got the typical output transformer sound of an iron core. So this was the Z11 core, and then I went to the amorphous, and I got just the tinge of the amorphous core, because the choke that I used is actually a power supply choke. It is actually not meant to be an audio grade choke, but it came out on top, and the amp sounded notably better than without it. So, but what I'm sort of touching home on is that the materials in this amp, so of whatever is powering the last the power out stage, still has a very notable, easily detectable quality of the materials used are just coming through in the amp. So that's that. And then a power supply, it's at the moment it's a CL, so a double pi filter, and then of course this one has its own pi filter, an extra pi filter to also decouple it from the main stage. It's probably a little bit overkill, but that's what it is at the moment. And as said, so there is a choke feeding the last stage as well. So it's sort of a CL power supply filter. Bit probably overdone, but we'll see. I'll still do a bit experiment. The rectifier, by the way, is a 5DJ4. It's one of my favorite rectifiers. High current, high input, very, I think, musical. Yeah, very good. Even though one of the core principles that went into this amp was actually to minimize the capacitors, and I have to say something final about the setup. So I'm using filament bias on here. This is an indirect heated tube, but I'm using Rod Coleman module to power to give DC to this tube, also these are all running on DC. So basically in this side of the amp it is mostly DC, so there's also no contamination. And it also means, because this is a very high amplification tube, which is normally, you'll see people online talking about this, is normally very prone to oscillations and so on. I just use a 270 ohm grid stopper, and that's it. It's completely stable. And that's very unique, I think, for this tube. But one of the reasons is because I'm using filament bias. And with that filament bias, I eliminated another cap. So we got an unbypassed common cathode resistor here. We got an unbypassed cathode resistor here. So I'm eliminating the influence of caps everywhere. And the only thing that is really exposed to the caps is the first stage. And it's quite minimal because of the high loading of the open secondaries, the interstage transformer loading. The voltage and the current will not change dramatically because it's so highly loaded. So it mostly operates as a voltage amplifier, so the influence of the cap powering it is quite minimal. But yeah, and I feel that normally whenever I'm able to remove capacitors without making serious compromises, as I'm doing here, the overall sound and transparency of the amp just increases, even with DC links used everywhere in this amp. So I'm not using anything else. Yeah, so that's the amp, that's the setup, the amp, the topology. It's used very rarely. I'll put a couple of links in the description, so to Steve Bench and also Lynn Olson, with regards to this type of setup of the output stage. I think it has very much its own sound. It's not single-ended, it's not push-pull, absolutely not push-pull. So it's more its own thing. I find it sort of, it has the harmonic spectrum of a single-ended amplifier, but it has the dynamics and the resolving capabilities, I find, of a push-pull, but without sort of its sonic downfalls. It is definitely not single-ended either, because I sometimes miss it a little bit. And this is, by the way, part 3 of the video where I sort of reflect back on this whole amp. In some ways, yeah, it's so much its own thing, but I find this is the only acceptable topology I find to implement push-pull. I don't like push-pull. This is sort of the only thing acceptable, and I still a little bit miss the charm of a single-ended amplifier. Like, I think one of my most intelligent amp was the 2646 Type 50 amp, and that still holds a lot of promise, I think, but it's extremely hard to execute well and needs really high quality interstage transformers. You need to really pay attention to the way the power is done there. It's all just very it's not easy to build really well. Where this is probably a little bit easier, and has some outstanding qualities of itself, and I can't mix the two. There's probably a space for both of them, because this amp is just extremely articulate and just does so many things well, and it's still addictive, but it doesn't have the charm of a single-ended amp. It just has its own maybe mantle of love that it covers. The way it packages the music to be consumed is just really nice. And it's not that this isn't engaging, but it's just a different experience. However, I do feel that with my high efficiency speakers, which is vintage Altec woofers, which are highly efficient, coupled with a highly efficient compression driver, that this feels like this is the type of amp those speakers were designed for. I don't know why, but it just feels what it coaxes out of those speakers. And I'll just give you a quick look. What it coaxes out of these speakers is just, it just feels like these drivers were developed for this type of amp somehow. I can't really tell you why, but that's my gut feel impression of it. So what's ahead? This amp is going to get more refined. I might even package it up in a really sweet looking amp and just have it there. I need to scrabble some funds together to you know, to have a double set of completely everything that I need, so that I can build probably maybe a single-ended amp and a push-pull or what is it, a differential amp like this, and or have this as a reference or so next to my new build projects. Anyway, that's the overview of my new amp. This has been a bit longer video. I hope you don't mind. If you have any questions, comments, thoughts, put them in the comments. Thank you to all my Buy Me a Coffee supporters. You really make a difference, and it is very nice to see to get these donations, and they are being used to buy components like they are in this amp, or the tubes and so on. I've got a couple more ideas. I want to definitely explore loading, especially tube loading, because I think there's a lot of very interesting trade-offs happening by loading the tubes harsher. Especially if you're interested in more lifelike dynamism of sound. The harsher loads, so the lower loading, works very nicely with that, and that's some of the experiments I'm going to do with this amp as well. Anyway, thank you for tuning in, thank you for subscribing to my channel, and I'll hope to catch you in the next video. Until then, have a great day, have a great week, and as said, I hope to catch you soon. Bye bye for now.